May 26, 1940. The White House, Washington, D.C. Radio engineers adjusted microphones as President Franklin D. Roosevelt prepared for one of the boldest statements in American history. His address would echo across a nation still wrestling with economic hardship, still recovering from the waves of unemployment that had battered both cities and farms. We must produce 50,000 airplanes within the next 12 months, the president declared. 50,000 warplanes to safeguard democracy itself. Across the Atlantic, inside the Reich Chancellery in Berlin, German military analysts pored over the transcript of Roosevelt's speech. They examined the figures with a mix of amusement and skepticism. When the translation was delivered to Adolf Hitler, his advisors assured him it was merely American propaganda. No country could achieve such output, they insisted. The United States had built fewer than 3,000 military aircraft the previous year. This was an absurd fantasy meant only to intimidate. Hitler accepted their conclusion. The arithmetic appeared to justify their disbelief. In 1939, U.S. aircraft production had totaled just under 3,000 planes. The industrial base was minimal. The workforce was inexperienced. Factories were tooled for automobiles, not bombers. Yet Roosevelt had just pledged to expand production by over 1,600% in a single year. The German High Command dismissed it as desperate posturing from a nation lacking both the machinery and the resolve to become a military superpower. What neither Hitler nor his staff grasped was that they were about to witness the greatest industrial mobilization in human history. The sleeping giant Roosevelt referred to was not America's military strength. It was its industrial might. The auto plants of Detroit, the shipyards along the Pacific coast, and the steel mills of Pennsylvania would soon prove that U.S. productivity could eclipse every expectation of modern warfare. The Germans had measured divisions and battalions, but they had not accounted for what would soon emerge from American assembly lines. December 7, 1941. Pearl Harbor, Hawaii. Japan's attack thrust America into global war. But while the military scrambled to respond, something even more profound was already unfolding across the nation's industrial landscape. The conversion had begun months earlier, accelerating week by week. Automobile assembly lines were being dismantled and redesigned. Factory floors were retooled. Workers were retrained. The most sweeping economic transformation in modern history was gaining unstoppable momentum. William Knudsen, former president of General Motors, had been appointed by Roosevelt to lead the conversion effort. In early 1941, Knudsen made a phone call that would alter the course of the war. He called K.T. Keller, head of the Chrysler Corporation. "Mr. Keller," Knudsen asked, "can Chrysler build tanks?" Keller's answer was simple and honest. "I don't know. I've never seen one. But if you give us the plans, we'll figure it out." Within weeks, construction began on what would become the Detroit Arsenal tank plant. Architect Albert Kahn, a pioneer in industrial design, drafted plans for a facility unlike anything ever built. The main structure spanned 113 acres, with walls 3 feet thick in some places. Reinforced concrete meant to withstand bombing raids. The assembly system would revolutionize armored vehicle manufacturing. Even more remarkable was the speed. Ground was broken during the winter of 1940-41, and by April 24, 1941, the first M3 medium tank rolled off the assembly line, even before the building was complete. Workers erupted in cheers as the tank, fully armed and functional, fired its guns in a nationwide broadcast demonstration. The pace astonished Allied observers. British tanks still required meticulous hand-fitting and customization, with each unit almost unique. German tanks, while more standardized, still depended heavily on skilled craftsmen and laborious assembly. The Detroit Arsenal introduced true mass production to armored warfare. Albert Kahn went on to design more than 20 million square feet of defense plants in 1941 alone. His innovative layouts applied auto industry production methods to military hardware. Open floor plans enabled seamless workflow. Overhead, cranes transported massive components efficiently. Sub-assembly lines fed main assembly sequences with mechanical precision. The outcome was production speed that defied all precedent. By December 1942, the Detroit Arsenal achieved a monthly record: 896 M4 Sherman tanks completed in a single month. That was more than Germany produced in the same period across all its factories. The plant ran day and night. 3 shifts of workers, many of them women entering factories for the first time, sustaining continuous output. President Roosevelt and First Lady Eleanor Roosevelt toured the facility in September 1942, observing tanks take shape through dozens of perfectly synchronized operations. It was industrial choreography on an epic scale. Over the course of the war, the Detroit Arsenal produced 22,234 tanks, roughly 1/4 of all U.S. tank output. What had been farmland in 1940 had become, by 1942, the most productive armored vehicle plant on Earth. Efficiency defined every process. Parts arrived from suppliers across the Midwest, stored in vast organized warehouses, then moved precisely according to schedule. Welders joined hulls, mechanics installed engines, electricians wired radios, and armorers mounted weapons. At the end of the line, completed tanks rolled out under their own power and onto rail cars bound for ports and training centers. The transformation was not limited to tanks. Across Michigan, the auto industry converted to wartime production at breathtaking speed. In Ypsilanti, Henry Ford's vision took shape. The Willow Run bomber plant, the most ambitious aircraft factory ever conceived. Charles Sorensen, Ford's vice president of production, had visited Consolidated Aircraft in San Diego in early 1941. What he saw disturbed him. The B-24 Liberator bomber was being assembled with outdated, inefficient methods that belonged to another era. There were no blueprints, no precision measurements, no standardized components. Each aircraft was essentially hand-built. Final assembly took place outdoors in the California sun, where temperature variations distorted metal components and made consistency impossible. Sorensen watched workers custom-fitting parts, hammering sheet metal into rough alignment, making individual adjustments on every single plane. He turned to his hosts with barely concealed frustration. "This is how we built cars 35 years ago at Ford." That night, in his hotel room at Call's, the Coronado, Sorensen sketched a revolutionary concept on hotel notepaper. He envisioned a factory 1 mile long and 4 mile wide. The B-24 would be broken down into major assemblies. Wings, fuselage sections, tail assemblies, and engine mounts would be built in parallel sub-assembly lines. These components would then converge on a main assembly line, where bombers would come together with the precision and speed of automobile production. Sorensen's sketch, initialed by Edsel Ford and his team the next morning, became the blueprint for Willow Run, a factory so ambitious that skeptics immediately dubbed it "Will It Run?", questioning whether Ford could possibly make good on such outrageous promises. Construction began in spring of 1941. The federal government contributed $200 million. Ford contributed engineering expertise and management. The facility that emerged was unprecedented in scale, and 500,000 square FT under one roof. An assembly line 1 mile long with a 90-degree turn halfway through to avoid extending into neighboring Wayne County, where property taxes were higher. The L-shaped factory became the largest room under one roof in the world at that time, but building the factory proved easier than mastering bomber production. Ford's engineers discovered that aircraft manufacturing demanded tolerances far more precise than automobile production. A car door that was off by 1/16 of an inch might close poorly. An aircraft wing assembled with similar tolerances would create fatal aerodynamic problems. The first year was difficult. In 1942, Willow Run produced only 56 B-24 bombers. Critics pounced. The facility had cost $200 million and employed 20,000 workers, yet produced fewer bombers per month than Consolidated San Diego plant had been making before the war. Newspaper editorials questioned whether mass production techniques could ever be applied to complex military aircraft. Some aviation experts argued that bombers required skilled craftsmen, not assembly line workers. Ford's reputation was at stake. The company that had revolutionized automobile production with the Model T and the moving assembly line was failing at its most ambitious project. But Ford persisted. Engineers redesigned jigs and fixtures. Workers received intensive training. Production methods were refined through trial and error. Quality control systems were implemented. By summer of 1943, the transformation was complete. On November 3, 1943, the 1,000th B-24 rolled off the Willow Run assembly line. The milestone was celebrated with a ceremony attended by military officials, government representatives, and thousands of workers. More importantly, production was accelerating. By early 1944, Willow Run was operating at full capacity. In April 1944, the plant produced 453 bombers in 468 hours. One complete bomber rolled off the assembly line every 63 minutes. The pace was relentless and unprecedented. The workforce at Willow Run reflected the social transformation sweeping through American industry. By the end of 1943, 42,000 workers labored at the plant. Women comprised a significant portion of the workforce. These were not women who had worked in factories before the war. They were housewives, teachers, secretaries, shop clerks who had answered the call for defense workers. They learned to rivet aluminum sheets, install electrical systems, operate precision machinery. The government launched massive campaigns to recruit women into industrial work. Rosie the Riveter became the symbol of female war workers. But beyond the propaganda posters, real women were mastering complex technical skills and maintaining production schedules that military victory demanded. The scale of social change was remarkable. In 1940, unemployment had stood at 14.6%. By 1944, unemployment had fallen to 1.2%. The economy had achieved full employment. But more significantly, approximately 6.5 million women entered the industrial workforce during the war years. These women worked as welders, machinists, crane operators, inspectors, and supervisors. They handled jobs that had been exclusively male domains before the war. The change wasn't limited to gender. African-Americans also found unprecedented opportunities in defense industries. The Great Migration accelerated as black workers moved from the rural South to northern industrial cities seeking defense jobs. While discrimination persisted, the urgent need for labor opened doors that had been closed before the war. The numbers tell a story of transformation that went far beyond military production. 24 million Americans relocated during the war years, seeking defense work, military service, or opportunities in booming war industries. Cities like Detroit, Los Angeles, Portland, and Seattle saw their populations surge. Housing shortages became acute. Government authorities rushed to build temporary housing for defense workers. Trailer parks, dormitories, and prefabricated housing units sprouted near major factories. The social fabric of America was being rewoven by the demands of industrial mobilization. At Willow Run, production continued to accelerate through 1944 and into 1945. By the time the last B-24 rolled off the assembly line in June 1945, the plant had produced 8,685 bombers. Additionally, Willow Run had produced approximately 1,893 knockdown kits. These were complete disassembled bombers that could be shipped overseas and assembled near combat zones. The knockdown kits solved a critical logistics problem. Flying bombers across the Atlantic consumed enormous quantities of fuel and exposed aircraft to weather damage and mechanical problems. Shipping disassembled bombers by cargo ship, then assembling them at forward bases, proved more efficient. The economic impact of Willow Run was equally impressive. The cost to produce a B-24 in 1942 had been $238,000 per aircraft. By 1944, through improved efficiency and mass production techniques, the cost had fallen to $137,000 per aircraft. This 42% cost reduction achieved, while dramatically increasing production speed and maintaining quality, demonstrated the power of Ford's production system applied to military equipment. Tragically, Edsel Ford, who had championed the Willow Run project from its inception, died on May 26, 1943. He was only 49 years old. Stomach cancer, exacerbated by the stress of managing the bomber plant during its difficult early period, took his life just 6 months before Willow Run reached full production. He did not live to see his vision fully realized, though his leadership had been instrumental in transforming the troubled plant into the most productive bomber factory in the world. While tanks and aircraft captured public attention, another industrial miracle was unfolding at American shipyards. The Liberty Ship program represented mass production applied to shipbuilding on a scale never before attempted. Before the war, American shipyards had operated at a leisurely pace. Building a cargo ship typically required a year or more. Skilled shipwrights hand-fitted components. Riveting was performed by teams of specialized workers. Each ship was essentially custom-built. The German U-boat campaign in the Atlantic changed everything. British and American merchant ships were being sunk faster than traditional shipbuilding methods could replace of them. In 1941, the situation was becoming desperate. Britain depended on Atlantic convoys for food, fuel, and military supplies. If the U-boat won the tonnage war, Britain would be starved into submission regardless of military outcomes elsewhere. Henry Kaiser, a construction engineer who had built dams and highways but had never built ships, proposed a radical solution. Standardize the design, prefabricate components, use welding instead of riveting, apply mass production techniques to shipbuilding. Traditional shipbuilders were skeptical. Ships, they argued, required craftsmanship that couldn't be mass-produced. Kaiser disagreed. He believed that breaking shipbuilding down into standardized steps, training workers in specific tasks, and coordinating the assembly of prefabricated sections could dramatically increase production speed. The government, desperate for tonnage, gave Kaiser the opportunity to prove his theories. The Liberty ship design was based on a British steamer modified for quick construction. The vessel was 441 feet long, with a beam of 57 ft. It could carry 10,000 tons, tons of cargo at a cruising speed of 11 knots. The design was deliberately simple. No necessary features, no architectural flourishes, just a functional cargo vessel that could be built quickly and cheaply. Each Liberty ship required 250,000 parts manufactured at factories across the country. The parts were shipped to shipyards where they were assembled into major sections. These sections, bow, stern, deck houses, holds were then welded together. Approximately 114 mi of welded joints held each Liberty ship together. This represented roughly 600,000 ft of welding per vessel. The magnitude of the welding work was staggering. Kaiser established shipyards in Richmond, California, and Portland, Oregon. Other companies established Liberty shipyards in Baltimore, Houston, and along both coasts. At peak production in 1944, American shipyards were launching 3 Liberty ships per day. The most famous production record was set in November 1942 at Kaiser's Richmond Yard. The SS Robert E. Perry was launched just 4 days, 15 hours, and 29 minutes after its keel was laid. This extraordinary feat was achieved through extensive prepositioning of materials and represented a publicity demonstration rather than standard production. The ship required additional fitting-out work after launch and was not truly complete in that time frame. Nevertheless, the demonstration proved that radical speed was possible with proper organization. More representative of actual production were the median construction times achieved by 1943 and 1944, ships that had taken 244 days to build in early 1941 were being completed in 39 to 42 days by mid. This six-fold improvement in construction speed was achieved through continuous refinement of techniques, better coordination of suppliers, and increasingly skilled workforces. By the end of the war, American shipyards had produced 2,710 Liberty ships. 18 different shipyards participated in the program across 5 years of production from 1941 to 1945. The Liberty ships, despite their unglamorous appearance and modest performance, proved instrumental to Allied victory. They survived the Atlantic crossing in sufficient numbers to sustain British resistance. They carried the vehicles, supplies, ammunition, and fuel that sustained Allied armies in North Africa, Italy, and France. After the war, many Liberty ships continued serving in merchant fleets around the world. Some remained in service into the 1960s and 70s. Their simple, rugged construction proved remarkably durable. But their true significance was demonstrating that even complex products like ocean-going ships could be mass-reduced by relatively unskilled workers using proper systems and organization. The scale of American shipbuilding during the war extended far beyond Liberty ships. The total production included 5,477 merchant ships of all types. This included tankers to carry oil, troop transports, refrigerated cargo ships, and specialized vessels. The U.S. Navy simultaneously was building warships at unprecedented rates. Aircraft carriers, battleships, cruisers, destroyers, submarines, and smaller vessels poured from naval shipyards. Additionally, American yards produced approximately 89,000 landing craft of various types. These included the famous Higgins boats that would carry troops onto the beaches of Normandy. Andrew Higgins, a New Orleans boat builder, had designed a shallow draft boat with a bow ramp for use in Louisiana swamps and marshes. The military recognized that this design, scaled up and armored, would be ideal for amphibious assaults. Higgins Industries would eventually produce over 20,000 landing craft, contributing significantly to Allied amphibious capabilities. The industrial mobilization extended into areas that received less public attention but were equally critical. American factories produced 193,000 artillery pieces during the war. These ranged from small anti-tank guns to massive howitzers. The production of 86,000 tanks represented a tremendous expansion from pre-war levels when American tank production had been negligible. 2 million Army trucks were manufactured, providing the mobility that allowed American and Allied forces to conduct rapid operations once ashore in Europe. The Red Ball Express, the truck convoy system that sustained Allied armies advancing across France in summer and fall of 1944, depended entirely on American-built trucks. The statistical magnitude of American war production becomes clearer when comparing outputs to enemy capabilities. By 1944, American industry was producing approximately 2/3 of all Allied military equipment. This meant that American factories were supplying not just American forces, but significant portions of British, Soviet, French, and other Allied militaries. Lend-lease shipments carried American-made tanks, aircraft, trucks, and supplies to Allied nations. The Soviet Union, while producing impressive quantities of its own equipment, relied heavily on American trucks, food, and raw materials. Britain's industry, stretched to capacity and vulnerable to bombing, depended on American production for many specialized items. The transformation of American industry required more than just factory construction. It demanded unprecedented coordination between government and private industry. The War Production Board, established in January 1942, controlled allocation of raw materials, established production priorities, and resolved conflicts between competing demands. Steel, aluminum, copper, and rubber were allocated according to military necessity. Civilian production was curtailed or eliminated entirely for many products. Automobile production for civilian use ceased in February 1942. The last civilian car rolled off assembly lines and wouldn't resume until after the war ended. Factories that had built refrigerators, washing machines, and other consumer goods converted to military production. The rationing system extended to civilian consumers. Gasoline, meat, sugar, coffee, and numerous other commodities were rationed to ensure adequate supplies for military needs. The story of RGLNO illustrates the entrepreneurial innovation that flourished during the mobilization. LNO was an inventor and manufacturer of earth-moving equipment. Before the war, his company had produced innovative scrapers, dozers, and other heavy equipment. During the war, Leona factories produced approximately 70% of all earth-moving equipment used by Allied forces. His innovations included massive scrapers that could move enormous quantities of earth quickly, allowing rapid construction of airfields, roads, and fortifications. Lowe held approximately 300 patents over his lifetime, with 78 granted during the war years alone. His equipment proved essential for military engineers, building the infrastructure that supported modern mechanized warfare. The technological innovations developed during the war would have lasting impact on post-war industry and society. Synthetic rubber production developed frantically after Japanese conquests cut off natural rubber supplies from Southeast Asia became standard for automobile tires and numerous other applications. Radar technology invented by the British and refined through American mass production revolutionized aviation safety and weather forecasting. Advances in metallurgy, chemistry, and manufacturing processes developed for military needs found civilian applications. The proximity fuse, developed to make anti-aircraft fire more effective by detonating shells near targets rather than requiring direct hits, found post-war applications in industrial automation and control systems. Perhaps the most significant long-term impact was on management techniques and organizational capabilities. The experience of coordinating massive industrial enterprises, integrating complex supply chains, and maintaining quality control across thousands of factories taught lessons that shaped American business for decades. The techniques pioneered at Willow Run and the Detroit Arsenal became case studies taught in business schools. Production management, inventory control, quality assurance, and workforce training methods developed during the war influenced post-war manufacturing across all industries. The scale and complexity of wartime production forced innovations in management that might not have emerged for decades under peacetime conditions. The human dimensions of the mobilization were profound and lasting. The experience of working in defense plants gave millions of Americans new skills, new confidence, and new aspirations. Women who had mastered complex industrial jobs during the war often found the return to purely domestic life unsatisfying. While many women did leave factory work when men returned from military service, the experience had demonstrated capabilities that couldn't be forgotten. The seeds of the women's movement that would emerge in the 1960s and 1970s were planted partly in the wartime factories where women had proven they could perform any job given proper training and opportunity. For African American workers, the wartime experience was similarly transformative. The Fair Employment Practices Committee established by presidential order in 1941 made discrimination in defense industries illegal. While enforcement was inconsistent and discrimination persisted, the principle had been established. Black workers gained access to skilled jobs, higher wages, and union membership that had been denied before the war. The experience of contributing to the war effort while still facing discrimination sharpened demands for civil rights. Veterans returning from fighting against fascism abroad were less willing to accept racial oppression at home. The civil rights movement that would transform America in the 1950s and 60s drew energy partly from wartime experiences of what was possible when all citizens were allowed to contribute. Though, economic transformation was equally dramatic. An economy that had struggled with persistent unemployment throughout the 1930s achieved full employment by 1943. Total industrial production doubled between 1940 and 1944. This represented the most rapid economic expansion in American history. The gross domestic product grew from approximately $100 billion in 1940 to over $200 billion by 1945. This growth was driven almost entirely by war production, but it demonstrated productive capabilities that would sustain post-war prosperity. The infrastructure built during the war, the factories, the power plants, the transportation networks continued to benefit the economy for decades. The post-war challenge of recon conversion proved less difficult than many feared. Planning for the transition from military to civilian production began as early as 1944. The War Production Board faced difficult decisions about when to release industries from war production contracts. Release them too early, and military supplies might falter. Release them too late, and the post-war economy might collapse. The balance was delicate but was managed successfully. Tank production ended abruptly when Germany surrendered in May 1945. Aircraft production continued through Japan's surrender in August, then stopped immediately. The cancellation of war contracts created temporary unemployment as defense workers were laid off, but conversion to civilian production proceeded rapidly. Factories that had built tanks returned to building automobiles. The pent-up demand for consumer goods accumulated during years of rationing and shortages drove rapid recovery. Americans who had saved money during the war because there was little to buy suddenly had purchasing power. The automobile industry, having produced virtually no civilian vehicles since early 1942, faced overwhelming demand. Housing construction, which had been minimal during the war years, boomed as veterans married and started families. The GI Bill provided veterans with access to education and home mortgages, further stimulating economic growth. The international impact of American industrial dominance shaped the post-war world. The Marshall Plan, which rebuilt Western Europe, was possible only because America possessed the productive capacity to supply both its own needs and the needs of devastated allies. American factories produced the machinery, vehicles, and equipment that European nations needed to reconstruct their economies. The Cold War competition with the Soviet Union was sustained by American industrial strength that could simultaneously produce consumer abundance and military power. The prosperity of the 1950s and 1960s rested on industrial foundations laid during the war years. The legacy of World War II industrial mobilization continues to resonate. The experience demonstrated that democratic societies, when threatened, could mobilize resources and organize efforts on a scale matching or exceeding totalitarian regimes. The production achievements proved that free people working voluntarily toward common goals could outproduce coerced labor. The industrial might that won the war became a foundation for lasting prosperity and global influence. The arsenal of democracy had fulfilled its purpose through the creative capacity of its people and the productive power of its industry. The magnitude of American industrial achievement becomes clear when examining specific production totals across all categories. Beyond the nearly 300,000 aircraft produced during the war years, American factories delivered 86,000 tanks to armored divisions. These tanks equipped not just American forces, but British, Free French, and other Allied armies through Lend-Lease transfers. The Sherman tank, despite its limitations against German Tigers and Panthers, proved reliable and maintainable under field conditions. Its real advantage was numbers. For every German heavy tank, there were dozens of Shermans. When one Sherman was destroyed, 3 more were available to replace it. German tankers might win individual engagements, but they could not overcome the relentless arithmetic of American production. Artillery production totaled 193,000 pieces. These ranged from small pack howitzers that could be disassembled and carried by mules to massive railway guns that could shell targets miles behind enemy lines. American Artillery doctrine emphasized mass firepower. Forward observers could call down devastating concentrations of fire on German positions within minutes. This capability depended entirely on having sufficient artillery pieces and unlimited ammunition. American factories supplied both. The shell production alone was staggering. Billions of artillery shells, mortar rounds, and small arms ammunition were manufactured during the war years. Ammunition ships crossed the Atlantic in convoy, supplying the massive expenditures required by American operational methods. The production of 2 million army trucks provided mobility that transformed warfare. Previous armies had relied heavily on railroads for supply. Combat units might advance beyond railheads, but sustaining operations far from railroads proved difficult. American armies in Europe and the Pacific operated with unprecedented mobility because truck convoys could maintain supply lines across hundreds of miles of territory. The famous Red Ball Express, which sustained Patton's advance across France in summer 1944, involved 33,000 soldiers driving 6,000 trucks along dedicated routes. At peak operation, the Red Ball Express delivered 12,000 tons of supplies daily to forward combat units. This logistical achievement was possible only because American factories had produced trucks in quantities that seemed excessive until they were actually needed. Small arms production matched the scale of heavier equipment. American factories manufactured millions of M1 Garand rifles, M1 carbines, Thompson submachine guns, and Browning automatic rifles. These weapons equipped not just American forces, but supplied Allied armies whose domestic production proved insufficient. The M1 Garand, adopted just before the war, gave American infantry a significant advantage. It was the only semi-automatic rifle issued as a standard infantry weapon during the war. German, British, Japanese, and Soviet infantry still used bolt-action rifles that required manual cycling between shots. The Garand's 8-round clip and semi-automatic action provided superior firepower. General George Patton called it the greatest battle implement ever devised. But the technical superiority mattered only because American factories produced Garands in sufficient quantities to equip every infantryman. The mobilization extended beyond purely military production. The nation's merchant marine expanded dramatically to carry military cargo and maintain international trade. In addition to the 2007-10 Liberty ships, American yards produced specialized vessels, including 512 faster Victory ships that could maintain 15 knots compared to the Liberty's 11-knot cruising speed. Tankers were built to carry oil from American and Caribbean sources to European and Pacific theaters. Without adequate tanker tonnage, the mechanized Allied armies would have been immobilized for lack of fuel. T2 tankers standardized like Liberty ships were produced in large numbers. Refrigerated cargo ships carried food. Troop transports carried soldiers. Hospital ships evacuated wounded. Each specialized vessel type required different designs and equipment, yet all were produced in quantities sufficient to meet expanding needs. The aircraft production of nearly 300,000 planes included extraordinary variety. Heavy bombers like the B-17 Flying Fortress and B-24 Liberator conducted strategic bombing campaigns against Germany and Japan. Medium bombers like the B-25 Mitchell and A-20 Havoc supported ground forces and attacked tactical targets. Fighter aircraft, including the P-38 Lightning, P-47 Thunderbolt, and P-51 Mustang, provided air superiority and ground attack capabilities. Naval aircraft operated from the rapidly expanding fleet of aircraft carriers. Transport aircraft, like the C-47 Skytrain, carried paratroopers into combat and supplied isolated units. Training aircraft taught hundreds of thousands of pilots the skills needed for combat. Each aircraft type required different tooling, different components, different assembly techniques. Yet, the industry managed to produce all these variants simultaneously. While continuously improving designs based on combat experience, The logistical challenge of supplying raw materials to this industrial empire was immense. Steel production expanded to meet military demands while maintaining essential civilian needs. Aluminum production increased dramatically to supply aircraft manufacturers. Copper for electrical wiring became so scarce that the government borrowed silver from the treasury to wind electromagnets for uranium enrichment at Oakage. Rubber supplies were cut off when Japan conquered Southeast Asian sources. A desperate program to develop synthetic rubber succeeded just in time to prevent severe shortages. By 1944, synthetic rubber production exceeded pre-war natural rubber imports. This single achievement demonstrated American industrial adaptability and technical innovation under pressure. The workforce that accomplished this production miracle came from unexpected sources. Beyond the women and minorities who entered industrial work, the workforce included teenagers who left school to work in defense plants. Retirees returned to factory floors to contribute their skills and experience. Disabled workers found employment in positions that didn't require physical labor. The nation mobilized every available worker because full production required to it. Training programs taught industrial skills to people who had never worked in factories. High school students learned machine operation. Housewives learned welding. Farmers learned aircraft assembly. The programs succeeded because they were necessary. Victory depended on production, and production depended on having sufficient trained workers. The work itself was demanding and often dangerous. Factories operated around the clock on 3 shifts. Workers handled heavy machinery, dangerous chemicals, and high temperatures. Industrial accidents killed thousands of workers during the war years. Falls from scaffolding, machinery malfunctions, explosions, and fires claimed lives in defense plants across the nation. The urgency of production sometimes led to inadequate safety measures. Workers accepted the risks because they understood the stakes. Each day of delayed production meant more casualties among soldiers fighting overseas. The workers in Detroit, Willow Run, and shipyards everywhere knew that their labor directly affected whether their sons, husbands, and brothers would come home alive. This knowledge sustained them through long shifts, dangerous conditions, and personal sacrifices. The financial cost of the mobilization was staggering. The federal government spent approximately $300 billion on the war effort between 1941 and 1945. This was more than the government had spent in all previous years of American history combined. Defense spending peaked at over $80 billion annually in 1944 and 1945. This represented roughly 40% of the entire national economy devoted to military purposes. The money was raised through taxes, war bonds, and borrowing. Tax rates increased sharply during the war. The income tax, which before the war applied mainly to wealthy Americans, was extended to most workers. Payroll deduction systems were introduced to collect taxes directly from paychecks. War bond drives encouraged citizens to loan money to the government by purchasing bonds that would be repaid with interest after the war. Despite massive government spending and high taxes, inflation was controlled through price controls and rationing. The Office of Price Administration established maximum prices for most goods and services. Rationing ensured that scarce commodities were distributed fairly, rather than going only to those who could pay the highest prices. The combination of price controls and rationing prevented the inflation that might otherwise have resulted from full employment and government deficit spending. Workers earned good wages in defense plants, but had limited opportunities to spend their earnings. Consumer goods were scarce or unavailable, rationing limited purchases of food and gasoline. Consequently, Americans saved money in unprecedented amounts. These savings accumulated during the war because there was little to buy, became purchasing power that drove post-war prosperity. The industrial mobilization created opportunities for entrepreneurs and established businesses alike. Henry Kaiser, who became wealthy building Liberty ships, was a construction engineer before the war. Howard Hughes expanded his aircraft business dramatically during the war years, though his most ambitious project, the massive H-4 Hercules flying boat, wouldn't fly until after the war ended. Wouldn't fly until after the war ended. Countless smaller manufacturers found profitable niches supplying components to prime contractors. Machine shops that had employed a dozen workers before the war grew into factories employing hundreds. The economic expansion created wealth that would sustain post-war growth. The end of the war brought difficult transitions. Women who had worked in defense plants were encouraged to yield their jobs to turning veterans. Many women resented being forced out of jobs they had mastered and found satisfying. The experience of working, earning good wages, and exercising skills had changed them. The post-war expectation that they would happily return to purely domestic roles ignored the transformation that had occurred. Similarly, African American workers who had found good jobs in defense industries faced renewed discrimination when peace returned. The wartime gains in employment and income proved temporary for many minority workers. These frustrations would contribute to social movements demanding equality in the post-war years. The recon conversion to civilian production proceeded more smoothly than feared. Automobile production resumed rapidly. By 1946, new cars were rolling off assembly lines, though production couldn't meet demand for several years. Housing construction boomed as veterans married and started families. The GI Bill provided veterans with access to college education and low-cost home mortgages. The resulting expansion of the middle class transformed American society. Suburbs grew rapidly as young families sought single-family homes with yards, shopping centers, drive-in restaurants, and car-oriented lifestyles emerged. The prosperity of the 1950s had its roots in wartime industrial expansion and post-war economic policies that channeled wartime savings into productive investments. The international implications of American industrial dominance shaped the post-war world order. The United States emerged from the war as the world's dominant economic power. American currency became the global reserve currency. American companies expanded internationally. American products found markets worldwide. The Marshall Plan, announced in 1947, committed billions of dollars to rebuilding Western European economies. This generosity served American interests by creating prosperous trading partners and allies against Soviet expansion. But it was possible only because American industrial capacity could supply both domestic needs and international commitments. The Cold War rivalry with the Soviet Union was sustained by American productive capacity. The massive military establishment maintained after the war depended on industrial resources that could simultaneously produce consumer abundance and military hardware. Soviet leaders understood they could not match American productive capacity. Their strategy emphasized conventional military forces and later nuclear weapons because they lacked the industrial depth to compete across all categories simultaneously. American strategic advantages throughout the Cold War rested on industrial foundations built during World War II. The lessons learned during the mobilization influenced American business and government for decades. The experience demonstrated that large-scale coordination between government and private industry could achieve results impossible through purely market mechanisms. The techniques of program management, systems engineering, and large-scale coordination developed during the war were applied to post-war projects, including the interstate highway system, the space program, and major weapons systems. The ability to organize massive technical efforts became a characteristic American strength. The technological innovations developed during the wartime mobilization had profound and lasting impacts that extended far beyond military applications. The development of the proximity fuse, designed to make anti-aircraft fire far more effective, marked a major leap in miniature electronics. Traditional anti-aircraft shells either required direct hits or had to be preset to explode at a chosen altitude. The new fuse contained a small radio transmitter and receiver. When the shell passed close to an aircraft, the reflected signal triggered detonation, greatly improving accuracy and lethality. Its value was so great that it was first used only over water to prevent recovery by the enemy. Later, proximity-fused shells proved devastating against German troops and armor during the Battle of the Bulge. After the war, the electronics developed for the fuse found new life in industrial automation, control systems, and more advanced electronic devices. Radar technology, originally pioneered by the British, was refined and mass-produced through American engineering. Early radar units had been bulky and unreliable, but U.S. scientists redesigned them for large-scale production, improving both precision and durability. Radar-equipped ships, planes, and ground stations enabled operations at night and in poor weather, guiding interceptors and detecting incoming threats. In peacetime, radar revolutionized aviation, allowing safe all-weather flight and air traffic control, while marine radar reduced collisions and improved navigation. Military metallurgy also advanced rapidly. Aircraft production demanded stronger, lighter aluminum alloys, while engines required high-temperature metals. Armor plate needed entirely new steel compositions. The resulting innovations elevated the entire field of metallurgy. After the war, industries benefited from these advances. Aluminum became central to construction, transport, and consumer products as costs fell due to wartime process improvements. Chemical industries expanded massively to meet wartime needs. Explosives, gases, and synthetic rubber were produced on an unprecedented scale. The urgent need for synthetic rubber after Japan cut off natural supplies created a permanent industry. Chemicals like DDT, first used to protect soldiers from disease-carrying insects, later revolutionized agriculture. The mass production of penicillin, scaled up to treat wounded soldiers, laid the foundation for the modern pharmaceutical industry and saved millions of lives. Wartime production methods permanently transformed American manufacturing. Techniques first used for cars were perfected for bombers, tanks, and ships. Lessons from the war shaped post-war production, introducing new standards for efficiency, quality control, and scheduling. Methods such as just-in-time inventory and streamlined workflow became hallmarks of American industry for decades. Training programs designed to rapidly teach industrial skills replaced slow apprenticeships. Technical schools and training within industry programs offered intensive hands-on instruction right on factory floors. These innovations continued after the war, forming the basis for vocational education and community colleges. The GI Bill sent millions of veterans to college, spurring a massive expansion of higher education. The war also revolutionized management practices. Large-scale military production required unprecedented coordination, giving rise to modern management tools such as program management, systems engineering, and critical path planning. These lessons spread to civilian industry through universities and business schools, shaping American corporate culture for generations. Social change was equally significant. Women entering defense factories challenged old gender roles. Though many returned home afterward, their wartime work proved their capabilities and inspired later movements for equality. For African Americans, the war accelerated migration to northern cities, where defense jobs offered better pay than the segregated South. The contradiction of fighting fascism abroad while facing racism at home fueled the civil rights movement that reshaped America in the 1950s and 1960s post-war. Prosperity rested on wartime foundations: vast industrial capacity, modern infrastructure, a skilled workforce, and advanced management systems. Factories, power plants, and transport networks built during the war continued to drive growth. The financial institutions created under the Bretton Woods system established the dollar as the world's reserve currency. While the IMF, World Bank, and Marshall Plan projected American economic power worldwide, NATO, supported by U.S. industry, anchored the post-war security order. The Cold War further tested America's industrial strength. Maintaining a large peacetime military and pursuing the space race demanded continuous innovation. The Apollo program's success drew directly on techniques refined during World War II. In contrast, the Soviet Union, despite military power, could never match America's productive might. Its chronic shortages and economic inefficiency eventually led to collapse, a defeat rooted in industrial competition that began decades earlier. The legacy of World War II's mobilization endures. It proved that democratic nations could mobilize as effectively as dictatorships, that free markets could support vast collective efforts, and that diversity was a source of strength. Ordinary citizens accomplished extraordinary feats when necessity demanded it. Though most wartime factories have vanished, their impact remains visible in the technologies, institutions, and prosperity that followed. In total, American factories built about 296,000 military aircraft, soaring from under 3,000. In 1939 to more than 96,000, it attained. 1944, Roosevelt's once impossible goal of 50,000 planes in a year was not only achieved, but surpassed. The sleeping giant had awakened, and its industrial power decided the fate of the modern world.